Alright guys, here we go. So yesterday we just looked at purely solving triangles. Now, let's look at how we get those triangles from a word problem. So first thing, recall angle of elevation, angle of depression. They're congruent. Remember, we got ourselves parallel lines because we must look always from a horizontal line. So these two angles are congruent by alternate interior angles because, well, horizontal lines are parallel to each other. This is not your angle of depression. This is your angle of depression, which is equivalent to the angle of elevation. So the angle of elevation from this person to the plane is the same as the angle of depression from the plane to the person. Those are congruent, okay? So I would suggest anytime you're working with one of these, just go ahead and draw a triangle like this. This is your right angle, that's your angle, either of elevation or depression. If you know the angle of elevation or depression, put the number there. If you don't, put your theta there, and then fill out the rest of the triangle. Now, let's talk about the parts of the triangles. So again, we got real life situations going on. On this first one, we got a ladder, and it's leaning against the wall. So this is the ladder, it's the hypotenuse. The ladder isn't straight up in the air, the ladder isn't on the ground. The ladder is your hypotenuse. And of course, we're going to make the assumption that the building, or whatever it's leaning against, is perpendicular to the ground. Those are two assumptions, well, one assumption we must make. And the height is however high the ladder reaches off of the ground up the building. So the building could keep going up and up and up, and however tall it says the ladder is on the building, that's the height. This is the foot of the ladder, and this is the base of the building, and that's how we'd measure the distance apart. If it says the ladder is 5 feet from a building, then you're going to be talking this distance right here, the foot of the ladder from the base of the building. Next one, we have this kite problem. And again, we're going to assume that we fly kites with our toes. So we have our horizontal distance that's directly below the kite, and then really the kite string is nice and straight. This is the angle of elevation to the kite, or the angle the kite makes to the ground, I guess you could say. But that's usually the angle we'd be talking about if we ask for an angle. This would be the horizontal distance, this would be the height of the kite. Right here we have a guy wire and a tree. Again, we're assuming perpendicular. The wire is the horizontal, the hypotenuse, sorry. Uh, the height of the tree, the height it goes up the tree, that's the vertical part. Base of the tree, this would be the angle the guy wire makes to the ground. You just have to read what's going on. We've got the shadow of the man right here, height of the man, angle the sun strikes the ground. And here you could go either way, angle of elevation or depression, whatever they tell you, just draw it like this. And this will be your angle, either of elevation or depression. This would be the altitude of the plane. That's the height above the ground the plane is. Horizontal distance, and if we drop something out of the plane, I don't know, a hammer, and we're trying to, whack-a-mole down here or something, who knows. This is the path the item would travel as it goes out of the plane, okay? It doesn't just stop going horizontally whenever you drop something out of the plane. It continues with the initial velocity of the plane. It's going to go like that. It doesn't just go straight down. So let's just set these up. I believe we did this one in class already, but let's do it anyway. A guy wire is attached to a tree 3 feet from the ground. So again, I'm going to draw most of my triangles just like this. Now let's see what's going on here. This is my guy wire. This is the wire. You do not need to write this on your figures. And if I think about it, the tree's taller than 3 feet. It's something like this, who cares? But this part right here, this is just 3 feet off the ground. So this part of the triangle right here is 3 feet, okay? It's not the whole tree. It's just, that's where the guy wire is attached to the tree at. So I tied it off right there. And the guy wire is 3.4, I should say feet long. And it wants the angle formed between the wire and the ground. Well, this is the tree. This is the wire. This is the ground. So this is the angle we're looking for. Now we have exactly what we had yesterday. Label your triangle. So this is my hypotenuse. This is my opposite. And again, every single page, maybe even every single problem, write down some old hippie caught another hippie tripping on acid. And hope by the end of the week, that'll be ingrained into your brain forever. So this one's going to be opposite hypotenuse, a sine problem. So let's write out what we have. Sine of our angle, which in this case is theta, equals opposite over hypotenuse. What am I looking for? I'm looking for an angle. So that means my angle is going to equal the sine inverse. Remember, shift sine of that ratio, 3 over 3.4. Go to my calculator. That's not my calculator. And type it in. So shift sine 3 over 3.4, excuse me. I get 61.9 degrees for theta. All right, let's look at the next one. We got a ladder leaning against the wall. So again, we got a wall, ladder's leaning against it. And how far from the wall is the foot of the ladder? That's the bottom, remember? So this is what we're going on looking for right here. Foot of the ladder to the wall, X. The ladder's 15 feet long, so that's the hypotenuse there. And the ladder leans against the wall at 52 degrees. Now you might be wondering, well, does the 52 degrees go here, or does it go here? And well, that's a great question. If we angle a ladder, this would be straight up and down, right? And we'd measure this angle right here to see what it is. Typically, if we're asking for a angle the ladder makes, we're talking about the angle it makes with the ground, not the angle it makes with the wall. Okay, just like your angle of elevation depression, it's with the horizontal. So if it's not specifying the angle the ladder makes with the wall, then it's okay to assume that's the angle it makes with the ground. That's what it means. So right here, this is 52 degrees. Sorry that my handwriting sucks and I'm writing small. Now, let's label. This is my angle right here. Who cares? That's my hypotenuse. This is my angle right here. That's my opposite. We don't care about it. This is adjacent. Let's use it. Now, we don't know the adjacent, but we don't even care about the opposite, right? Like, it has no number. We're not looking for it. We don't care. So, we're going to use adjacent and hypotenuse, which is a cosine problem. Write down what you got. Cosine of my angle, in this case, we know the number, it's 52, is equal to adjacent over hypotenuse. All right, what are we looking for? We're looking for a side. Take this, type it as you see it, shift, calc, equals. Let's do it. Cosine 52, make sure you close that parentheses, equals x over 15. Shift, calc, equals. 9.2, and it says to the nearest foot, so 9. So that means x is 9 feet. And we are dealing with real life situations, so go ahead and put the units. I won't take off points, but it's good practice, you know? I mean, we're talking about feet here. We're not talking about meters. 9 what? 9 feet, not 9 miles. It's not 9 miles away from a tree, okay? Or wall. Let's see. The sun's ray strikes the ground at 55 degrees, 20 meters from the base of a tree. So we got a tree, and we got the sun over here just beaming down on it. I like to draw my triangles like this. You could have drawn it the other way. You could have drawn it. Let me erase this extra piece first. So this is our triangle right here. We don't care about the ray. We don't care that the uh, sun's going either. It could go either way. It could go that way. We don't care. It doesn't matter. I typically draw mine facing this direction. Just I don't know why. I just do. But what we do care about is the angle the sun's ray strikes the ground. Strike. That means to hit it. Okay. So where is the sun ray hitting the ground? Is it hitting it right here? No, that's a tree. Is it hitting it right here? No, that's still a tree. Is it hitting it right here? Yeah, that's the sun ray and the ground. So this right here inside of our triangle is 55 degrees. Excuse me, sorry. Okay, 21 meters from the base of the tree. Base, treble. I don't know, what's a base? Oh, the base is the bottom. This is the base. If it says 21 meters from the base of the tree, we're not measuring up the tree, we're measuring from the bottom to the bottom, 21 meters. And it asks what the height of the tree is, so that's this part. Wait a minute, why does the sun go directly to the top of the tree? Because it's the sun, it's way the freak up in the sky. Anyway, let's see what we got. We don't have or care about the hypotenuse, so I'm not going to mark it. This is my opposite right here and adjacent right there. If you need to put the hypotenuse, do it. Doesn't hurt. You can do it every time if you need to. Or you can just mark what you know. And what we know is the adjacent. What we're looking for is the opposite. That means we're using tangent. Set up what we got. Tangent of our angle is equal to opposite over adjacent. And I'm trying to guesstimate where my head is right now. I can't tell. Like, you see how see this whole picture right there? I don't see that right now. I think I'm right above it, but I'm not positive. So tangent 55 is equal to x over 21. Sorry if you can't see that. In fact, let me just do that. Now you can see it for sure. So I'm going to type that in the calculator. Except I just forgot what it was. I think I remember. Yeah, tangent 55. Tangent 55 is equal to x over 21. Oh, let me do x over 21, right? Oh, why is that weird? Because that's not the x, that's the multiplication symbol. X over 21 equals. No. Left arrow key, shift, calc, equals 29.99. And let's scroll back up for a second. The direction said to the nearest meter. So we round 29.99 to the nearest meter. That's going to be 30 meters. Okay. Yes, yes, I know rounding's hard. I don't know why. But yes, it's 30 meters. Please put the meters. And don't put 30.0. It says round to the nearest meter. If you want to, you can put 30 point if you really want to, but just 30 is fine. We're not doing sig figs. All right, a little boy flies a kite. So again, we got ourselves a kite. It's going to go something like this in the air. So here's the boy, and he's stepping on it right here. And here's his hands right here, just holding nothing because he's stepping on the kite, right? He's flying it with his toes. The string forms an angle of elevation of 37 degrees. And of course, we don't care about the boy. We just need to draw our triangle. You know what? I'm going to make it a little bit bigger to make it easier to draw inside. There we go. Right angle, angle of elevation. Boom, don't even think about it. There's my angle right there. Depression, elevation here, right here. Stick it there. Uh, from where he stands to directly under the kite is 45 feet. So he's standing here. The kite's over here. And this says under the kite. That's down here. This is 45. Right there. That's the distance from the toes to underneath the kite. How long is the kite string to the nearest foot? So let's see. Is this the kite string going straight up into the air? No. This is it right here. Label your triangle. Hypotenuse, opposite, adjacent. Adjacent and hypotenuse. Oh no, where is my reference? I started a new problem on a new page, so I'm going to write it down again. Some old hippie caught another hippie tripping on acid. Okay, now I see it. I feel better. AH, adjacent hypotenuse, that's a cosine problem. Write down what you got. Cosine of our angle, which is 37 in this case, is adjacent over hypotenuse. Now, take this, type in your calculator, shift calc equals, call it a day. And if you're getting these, you can just skip through. You don't have to watch the whole video if you don't want to. But if it's helping you, great. If it's not, oh well, sorry. Shift calc, hey, calc, there we go, equals. And that one took about a tenth of a second to think. 56.34, it says nearest foot, so 56 feet, yeah. Alright, let's just go ahead and set up these other two real quick. Probably not throwing the calculator, let's just move on. Okay, actually, okay, never mind, I just changed my mind. We got a 10-foot ladder reaching a window that is 8 feet from the ground. So we got a ladder, we got a building, and we got a ground, and the ladder's going 8 feet up the building, it's 10 feet long, and we want the angle formed between the ladder and the wall. Oh, we want this angle, don't we? Why do we want that angle, not this angle? Because it says the ladder. That's this thing. And the wall. That's the angle between them. So let's see what we got. Hypotenuse. Change colors. Yes, change from red to red. That's going to work. This is going to be the, no it's not, is it? This isn't the opposite anymore. Because our angle's over here. So this is the opposite, which we don't care about. This is the adjacent. It changes. Remember, all these problems, they had the angle in the bottom left corner. But it doesn't have to be. Your angle could be either this one or this one. Is it going to be this one? No, that's your right angle. That's not going to be your angle. So it's either going to be this one or this one. And based on that reference angle, it decides which side is your opposite and which one's the adjacent. So in this case, this side over here is our adjacent. So let's write what we have. Adjacent, hypotenuse, cosine again. Cosine of my angle, which in this case we don't know, so I'm going to call it theta, is adjacent over hypotenuse. And to get that theta, is equal to the cosine inverse. Excuse me just for 1 second. I don't feel like editing it, so you can watch me drink water. Cosine inverse of 8/10. So theta equals, and this is actually a very common one. So let me see if I remember. I'm just trying to remember here. I think it's about 53 degrees. Let's find out. Shift cosine 8/10. It's either 53 or 56. I think it's 53. 36. Yep, okay. Then this one's going to be 56. 53. Okay, I got those backwards. Sorry. But these is your 3, 4, 5 right triangle. We'll see those angles a lot. But you don't need to remember them. Just type it in the calculator. 36.86, so nearest degree, 37 degrees. I lied to you. Sorry, it's not 56, it's 37. But yeah, you'll see this number a lot because this is one of your Pythagorean triples. It's a 3, 4, 5 times 2 right triangle. It's a shortcut that I told you about a few weeks ago. Do you remember? 3, 4, 5, 5, 12, 13. Yes, no. Why aren't you answering me? I'm like just talking to myself here. Fine, okay, moving on. An airplane spots the floating debris at an angle of depression of 15 degrees. Okay, angle of elevation, angle of depression, who cares? I'm drawing my triangle like this, and I'm sticking my angle right there. Boom. That's my right angle. Lovely square there. If the plane has an altitude of 3,000 feet, altitude, that's the horizontal distance, right? Hypotenuse. Height off the ground. Gonna start making some Dora videos. Some monkey's name again? I don't remember. Boots. Hey Boots, what do you think? I don't know. What is the horizontal distance? Horizontal. This part. This part right here. And again, I'm gonna just do this because you probably can't see that. So we got ourselves no hypotenuse. Tangent must be it. That's my opposite. That's my adjacent. Write it out. Tangent, excuse me, of my angle is opposite over adjacent. So 10, 15, 15. And now I forgot everything. 3,000 over x. 3,000 over x. Shift calc equals, too bad it's not flipped in like a 9,000 because then it'll be over 9,000. Which actually, hey, it is. Yeah. Any reference? Anybody get the reference? Who knows? To the nearest 100 feet. Ooh. I'm gonna actually do this. This. Take that and shove it in here. We have ourselves a big number, and it says to round to the nearest 100. This is my tenths. That's my hundredths. So I'm gonna round there, right? That's hundredths with a THS at the end. That's tenths with a THS at the end. That's your decimal point. This is your ones, no TH at the end. Tens, no TH. Hundreds, hey, that's what we're looking for, the nearest 100. So if I look at this, the next number is 5 or bigger. So we're using the old rounding rule, just going to go up to the next number because that's bigger than 5. So that means I'm going to keep these numbers the same. 1, 1, that's going to have a 2. So it's 112. We got these two guys still. This is 112 hundreds. So 112 hundreds. So do that, because fill the rest with zeros as placeholders for your place values. And don't put a decimal. You'd be wrong if you did that. I can't mark it wrong. I could, but no, don't do that. Based on sig figs, that would be wrong. So just don't do it, please. And if you don't know what sig figs are yet, you will one day. Anyway, moving on. I'm just rambling here. Let's look at this massive mess of a picture. You might be like, "Oh my God!" I hear Maya right now, just screaming about this picture. I do. Anyway, let's just break it down. Let's look at one. What the heck? The angle of elevation from the car to the top of the diner. So here's my car. Here's the diner. And we want the angle of elevation. So remember, we're always going from a horizontal line. Always horizontal. Doesn't have to be the ground. Could be the ground. But it's going to be parallel to the ground. So it's got to be this, or it's got to be parallel to this, or this guy, or this guy, or this guy over here. So we're never going to use an angle that doesn't involve one of those lines, right? So here's this one. So could we use this 20? No, that's not an angle of elevation or depression. Okay. But in this case, it says from the car to the diner. That's this angle right here. Now, these are not degrees. They're names. The name of this angle is 17. It could have easily been named Bob, but Mikey decided to call it number 17. Not degrees. Okay. So if we put two of these angles together, like if we want to know what this whole angle is right here, it's not 21. No, it doesn't have a name. Okay, just it's a 90-degree angle, but who cares? So yeah, be careful how you're looking at these things. Let's see. Let's look at diner. Yeah, this one's what I was looking for. Angle of elevation from the top of the diner to the top of the tall building. So this one's easy. The angle of elevation from the diner to the building is it's right here. Boom, 2. All right, and then if we look at it, what's the other way around? What's the angle of depression? Do they ask that one? They asked for the angle of depression from the tall building to the car. What's the angle of depression from the tall building to the diner, though? Well, if we look at that, that's going to be alternate interior with this guy, so that's at 6 right here. Okay, so the diner, angle of elevation from the diner to the building is this angle 2, that's its name. And from the tall building, the angle of depression to the diner is 6. You can see they're the same. Supposed to be. Kind of. Yeah. And let's look at the one it does ask, because students always get confused on this one. The angle of depression, let me see what number this is. From the tall building to the car, right here, number H. The angle of depression from the tall building to the car. Hey, that's a 7 right here, isn't it? There's no horizontal. See, 7's not anything, because it's not involving a horizontal line. So just no. It's actually this whole angle from the start of 7 up to this horizontal line, and they named that angle 18. It's kind of hard to tell, but that's what it is. And you can tell this angle 19 right here is never going to be used because it doesn't go up to a horizontal. Okay, so that's how you're going to do that one. I think I've explained it sufficiently well for you to be able to fill it out. Remember, it's got to be dealing with the horizontal, so this 22 right here is impossible to be used. So well, the 21 could be the angle of depression for the back of the plane of the boy, I guess. I don't know. But no, not really. This, yeah, the elevation for the boy to the plane is 15. No, it's not 15. 15 doesn't involve a horizontal line. So 15's nothing. It's actually this one right here, 16. Remember, it's got to involve a horizontal line. Okay, that's enough of that one. This is your work anyway, not mine. And then it says circle or draw the thing that it's talking about. So let's just do a couple. The angle the ladder forms with the wall. I'm personally going to draw it in there. Boom. Theta. That's a terrible, awful theta. Theta. Yeah. The length of a shadow. I'm going to just that kind of thing. And the length of the string versus the height of the kite. You can draw those. And then these, I think it's asking you to set it up. What? I don't remember. I think I forgot to put some pictures in here. Let's check, or I just didn't do them. Yeah, I just do them. Whatever. I am what I was going to do now. So, more of circling the things. The distance from the base of the tree to the guy wire in the ground. Base of the tree, guy wire in the ground. Height, where the guy wire is fastened to the antenna. Well, that's this thing. Wait, it's not this piece up here? No, we measure height from the ground up. The angle formed between the wire and the ground. This is the ground. That's the wire. Boom. And then you have these guys where you're just gonna, in this part, you're just gonna draw the picture. Label it like we did on these guys. Just draw it. Put your numbers in there. Label it opposite adjacent hypotenuse. And it's just draw it. Then you're gonna solve them down here. So you can take your drawing and use it up here, and then just write out what you got. Or you can just draw it again if you want to. I don't care. But you do need to show me. So it even kind of tells you this is looking for a side, 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 side angle. How do I know that so fast? Because that's got a theta and the rest of them have x's. All right. That's pretty much it. This video I think covers today and tomorrow really. Um, I'll look through tomorrow's lesson again just to be safe, but I think you should be good. And this paper should be in your binder from Friday, of Thursday, Friday of last week. Yeah, I gave you the sub's got like 5 extras if you need some, but it should be over there. Goodbye. Um, yeah. So message me with any questions. I'll be trying to make sure you don't do your English work during my class. You know who I'm talking to. And yeah, see ya when I see you. Bye, guys.